Hi, welcome to extra problem number 2 when we're working with exponential functions. And in this one we're going to find the time. The previous one we found the initial value, now we're going to find the time. So we have some problems to do. Let's see, don't forget to pause the video if you wish to work this out first. At the end of 21 days, 1/8 of the radioactive substance remain. What is the half-life period of the substance? So, if you read, what is the half-life? So we're trying to find, half-life is h, so we're trying to find what h is. And at the end of 21 days, so that means the time is 21. 1/8 of the radioactive material is there. So if we have A, so 1/8 of A is what big A is, because if it's 16, 1/8 of that is 2. If it's 8, 1/8 of that is 1. So big A, which is the amount that's left, is 1/8 of the original. And you can see because it's, and we have a half-life, so that means that the base is going to be 1/2 because it's half-life. So we have A, small a, base T over H. So the big A is 1/8 of, let's make that a small a, and go 1/8 of A. Small a, the base is half-life. The time is 21. And we're trying to find what at the end of 21 days, we have a half-life. So we're trying to find what the half-life is, which is the H. So again, it's 1/8. What remains is 1/8 of the original, so it's 1/8 of A. Half-life is the base. The time that expires is 21, and we're trying to find H, half-life. So the A's cancel out. We divide both sides by A, so 1/8 is equal to 1/2 of 21 over H. And 1/2, that's a half, so 1/2 is 1/2 to the third power is 1/8. Because they both have the same basis, that means 21 over H is equal to 3. And it's 3 over 1, cross multiply. 3 times H is 3H. 3 times 21 times 1 is 21. Divide by 3. So H is equal to 7. So the half-life is 7. If you go back and check, 21 divided by 7 is 3. 1/2 to the third power is 1/8. So 1/8 of A is what the remaining amount, that amount that's left is going to be. So the half-life is 7. Let's do another one. Don't forget to pause the video if you wish. If $2,000 investment triples in 6 years, how long will it take for the investment to be worth $54,000? So let's see. We have tripling. So I see this is, if this is the initial triples, if it $2,000, so that's the A value. $2,000 is going to triple, so that means your base is 3, and the tripling time is, let's put the tripling time is going to be 6 years, like your doubling time would be 6 years. This is tripling time is 6. And we have the large A, it's going to $54,000. And we have to find how long, so we're looking for T. So we have large A, small a, base, and we have T over C. So the large A is 54,000. The small a is 2,000. The base is tripling because it's 3. The tripling time is 6. So we are looking for how long will it take it to grow from 2,000 to 54,000. So we're looking for time. So 54,000 divided by 2,000. We divide by 2,000 on each side. And so that comes out to be 0 cancels. That comes out to be a 27. Make that a 27, cancel there. And we get 3 to the t over 6. So 27 is 3 cubed, and that's 3 to the t over 6. Both bases are the same, so t over 6 equals 3, and 3 is over 1, make both fractions. Cross multiply, 1 times t is t. 3 times 6 is 18. So it would take 18 years for $2,000 to grow to $54,000. Notice we put 18 back in. 18 divided by 3 is 18 divided by 6 is 3. 3 cubed is 27. 27 times 2 is 54. And it works out. Okay, let's continue. And we have another problem. Again, trying to vary the variety of the problems that I expose you to. We have investment plans. Plan A is investment plan. You're going to invest $64 and you're going to double every 5 years. Plan B, you're going to invest $16 and it's going to double every 3 years. Find the number of years when both plans are equal. Okay, so let's do Plan A. Plan A has, if you think of A, B, and this is doubling, so let's do D. So we have, start off at 64, and you're doubling, so the base is 2, and the doubling time is 5. So we're looking for the number of years. The number of years that we're looking for is T. So Plan B would be the same equation, but we have $16, and again it's doubling, and it's going to double every 3 years, and we want to find how many years it's going to take to grow. But both plans are going to be equal, so that means that 64, 2 to the t over, make that a t, over 5 is equal to 16, and that's 2 to the t over 3. So both of these are equal. So I have a, let's see, 64. Can 64 is 8 times 8. 8 got 3 2s, so that's a 6. 2 to the t over 5. 16 is 4 times 4, so that's 2 to the 4th. And because they're the same bases, then I put down the base, and I take 6. When you multiply these, you add your exponents, so it's t over 5. These are the same bases, so you add 4, add on t over 3. And you notice, let's go right here, that we have the same basis of 2's, so 6 plus t over 5 is equal to 4 plus t over 3. Because they have the same basis, the exponents are equal. Now we have fractions in here. What I do with fractions, I find the LCD and I multiply each side by the LCD. So I have a 5 and a 3, so the LCD is 5 times 3 is 15. So I will multiply each side by 15. When you do, you'll eliminate the fractions. So 15 times 6 is 90. 15 times t over 5, 5 into 15 goes 3, so it gives you 3t. 15 times 4 is 60. And t over 3 times 15, 3 into 15 goes 5, so that gives you 5t. So let's continue. Now, I move the variables to the left, make it a negative 5t. Move the numbers to the right, make it a negative 90. That gives me negative 2t equals negative 30. Divide by negative 2, and t is equal to 15. So in 15 years, both of these plans will have the same amount of money. And I could have asked you for when will it be the same? And if I put t back into either one of these two equations, so I put t here, I could get the amount of money. So that would be, if I put 15 here, I get 15 divided by 5 is 3, 2 to the 3 is 8, and 8 times 64. And if I put 15 here, 15 divided by 3 is 5, 2 to the 5 gives you 32. 16 times 32 is the same as 64 times 8. Check it out. And number 4, half-life of iodine 131 is 8 days. When will it be root 2 over 4 of the initial mass? So again, the equation is A equals A, B, and it's a half-life. It's a T over H. And so we have, it's a half-life, so we have the base is a half. So let's see, the half-life, so the base is a half. So we have the half-life, H is 8 days, so we can put 8 in. When will be, so we're looking for the time. So that's the time. When will it be root 2 over 4 of the initial mass? So if the initial mass is A, then the amount that remains is going to be root 2 over 4 times A. So we can divide both sides by A. So the A's cancel. So we get root 2 over 4 equals 1/2 to the T over 8. So what we have to do is try to get the same base, because in the next unit that we're going to do, which is the unit on logs, we'll be able to handle this at any time. But right now, to do exponentials, we need the same base. So 1/2 is 2 to the negative 1. So let's take root 2 over 4 and simplify it to a base 2. So root 2 is 2, and that's a 2 and a 1, so that's 1/2. 2 to the 1/2 is the same as the square root of 2. 4 is 2 squared. So because we have the same bases, we subtract the exponents, so there's a half, subtract 2. So that's 2, and 1/2, subtract 4 over 2, so 2 to the negative 3 over 2. So this becomes 2 to the negative 3 over 2. We have the same basis, so, and I have to make this a 2, so this is a negative 1 times t over 8 is a negative t over 8. Because of the same basis, I get a negative t over 8 equals negative 3 over 2. Cross multiply, negative 2t is negative 24. Divide by negative 2, and t is equal to 12. So in 12 years, it will be root 2 over 4 of his initial mass. And let's continue. We have another page to do. Oh, we have one more problem. Again, don't forget to pause the video. A bond pays an interest rate of 4% a month. Find the annual rate to the nearest tenth. So it pays 4% a month. So you're getting interest. So the base is equal to 1 plus your R. And the rate is 4. Oops. Let's do percent. Oh, sorry. 4% a month. So that means your base for a month, there's 4%. 4% is 0.04. So your base to work in terms of your exponential, your base is 1.04. But we want the annual rate, and the annual rate, annual is 12 months. So that means n is 12. So if you take the base and put it to the 12th power, and you take 1.04 to the 12th power, that will give you what you're going to have at the end of the 12th month. So that's your base. So if you go and you do that to the 12th power, that gives you 1.6. So B is your annual base. So B is your annual base is 1.6. So if your annual base B equals 1 plus R, 1.6 is 1 plus R. So R is 1.6 minus 1. So again, this is the annual rate, not the monthly rate. The annual rate is 0.6. And so that rate is 60%. So if you have 4% in a month and you compound it, then you'll end up with a yearly rate of 60%. So that means, if you think about it, I'm just checking, show you that if you take 1.04 for 12 months, that's the same as taking 1.6 and putting it to the 1 power for 1 year, and you get the same amount. So 1.04 to the 12 compounded is the same as if you got, so if you got 60% and you did your interest on 1 year at 60%, these two amounts would be the same, no matter what dollar value you put in, because that's the monthly rate compounded 12 times. And if you did 60%, which is 0.6 once, you get the same amount, same number. So no matter if you put in 1,000, 10,000, or 20,000, these two numbers are the same, so you get the same amount. Just wanted to show you that. Again, some extra problems. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.